So today we're going to learn about the inverse trigonometric function. So before we start doing any problems, I want to go over the inverse graph of the six trigonometric functions. So we need to go over the sine inverse, the cosine inverse, the tangent inverse, the cosecant inverse, cotangent inverse, and the tangent inverse. Because this is really important when you're graphing. Okay, so our sine inverse right here, our sine inverse has a domain of -1, right? -1 and +1, and the range is from -π½ to π½ The range is very important because this will tell us what quadrant we can plot it, what quadrants we can use. So for cosine inverse, we have the domain of -1 to +1, and then a range is from 0 to pi. So it's just it's in quadrant 1 and quadrant 2. The tangent inverse has a horizontal asymptote of on π½ and -π². So the domain is, as you can see, is all real numbers from -infinity to +infinity, right? And the range is from -π½ to π². And then the cosecant inverse is the domain is from -infinity parentheses comma 1 bracket union 1 bracket to +infinity, and the range is from bracket -π² to 0 union 0 to π². So this will come in handy when we do the problems. You'll see what I mean. So it's very important to know the domain and range for all the six trigonometric functions. And then our secant graph is our domain is from -infinity to -1 bracket union bracket 1 to +infinity, and then our range is from parentheses 0 to π½ parentheses union parentheses π½ to pi bracket, and then our last one is our cotangent inverse graph is our domain is from -infinity to +infinity. Yeah, -infinity to +infinity, and our range is from 0 to pi. Hold on, I'm not done with this graph. So it should look something like this. Okay, so those are your six trigonometric inverse function graphs. I would really just know where the range is, because the range tells us which quadrant we can use. So let's start doing problems. So we got to find the exact value of each expression without using a calculator or table. So our first problem is first one is arc sine of square root 2 over 2. You can actually rewrite this as sine inverse, because arc, sine, and sine inverse are the same, so you can rewrite it as sine inverse of root 2 over 2, right? So, well, what does this mean? So, what does it mean? I'll explain it in words. So, what they're really asking is, what degree in radians is it going to give you sine of root, where sine equals root 2 over 2, where alpha is a negative pi over 2 comma pi halves. So let me write this out. So what they're really asking is, what degree in radians is going to give you sine, where sine equals root 2 over 2, where alpha, or it could be alpha or theta, it doesn't really matter, is from negative pi over 2 to pi over 2. So where I got negative pi over 2 to pi over 2, it's basically the range of the sine inverse graph. So if you want to go back, you could go back and look over the sine inverse graph, and then that's how you get negative pi half to pi halves. So in order to do this, let me draw it first. So where our boundaries are from negative pi halves to pi halves. So we can only use quadrant 1, and negative pi half is over here, right? So we can only use quadrant 4. So what degree in radians is going to give you sine of root 2 over 2? I think that in quadrant 1, positive root 2 over 2, right? I could use pi over 4, right? Because pi over 4 has the coordinates of root 2 over 2, comma, root 2 over 2, right? So the sine is, this is the x and the y is the sine. So pi over 4 is one of the answers. Can we use negative pi over 4? Negative pi over 4 has coordinates of root 2, comma, negative root 2. So here's your x and here's your y. This is a negative root 2 over 2, so we can't use this one. Right? We can't use negative pi 4. We can only use pi 4 because it's positive root 2 over 2. So our final answer is pi over 4. Okay, let's do a new one. So let's do to number 2. We could say arc cosine of negative 1. Oops, cosine. Whoops, hold on. It's arc cosine of negative 1. How else we can rewrite it as cosine inverse, right? Because cos inverse in arc cosine is the same thing as cosine inverse of negative 1. So what are they really asking? So what they're really asking is, what degree in radians is going to give you cosine where cosine equals -1, where alpha is in 0, pi. Just to note, they will not really tell you what boundaries it is. You have to know the boundaries because we know that the cosine inverse graph has a range of 0 to pi. That's how we got this number. This is how we got these that boundary. So you really have to know your range for the 6 trigonometric function. Okay, so what degree in radians is going to give you cosine of -1? So let's draw the graph. So we can only use 0 to pi. So 0 is here and pi is around here. So we can only use quadrant 1 and quadrant 2. Okay, so cosine, let's try, can we use pi? The coordinates of pi is from -1, comma 0, right? Cosine, here's your x. Cosine is the same thing as x, right? Cosine is -1, so this is a possibility. Can we use 2 pi? 0? 0 is right here, right? And that gives you a coordinate of 1, comma 0. Nope, because we want a -1, so we can't use this. So our only option is just pi. So our final answer is just pi. Okay, let's do another one. So number 3, let's do secant inverse of 2. This one's kind of tricky because it's secant. Here, I'll go. So let me explain it in words. So in words, they're saying what degree in radians is going to give you secant equals +2, where alpha is in, so this is our boundaries from 0 to pi halves union pi halves to pi, and I got this boundaries from the secant inverse graph because this is our range. So first off, what is secant? Secant is really the same thing as 1 over cosine alpha, right? So we got to make what is 1? We need something 1 over something that'll give us 2. Okay, so I will say I'm going to try the radiant pi over 3. So let's try cosine of pi over 3, right? So that's really saying 1 divided by, what is the cosine of pi over 3? Is 1/2, right? Cosine of pi over 3 is 1/2. And then when I do the bracket, multiply everything by 2, because I want to simplify this, that gives you 2 over 1. So we get +2. So pi over 3 is one of the possibility, right? Because the reason why I'm using radians of pi over 3 is because that has a coordinate of 1/2. Comma √3 over 2. This is our x and this is our y. And we agree that if we put in 1/2 in cosine. Cosine of pi over 3 is 1/2. That gives us a secant of +2. So we could use pi over 3. Can we use, our boundaries is from 0 to pi halves to pi halves to pi. So we can only use quadrant 1 and quadrant 2. The reason why I'm not going to use 2 pi over 3, I'm not going to use 2 pi over 3, is because cosine is -1/2, right? We want a +2. If we use -1/2 here, we would get a -2. So we can't use 2 pi over 3. So our only answer is pi over 3. Okay, secant, let's do another one. So that was, let's do tangent inverse of -1. So in words, it's going to be asking, it's really asking you what degree in radians is going to give give you tangent, where tangent equals -1, where alpha is in negative pi halves to pi halves, right? So this is the range of the tangent inverse graph. So what is tangent really? Tangent is y over x, right? Tangent over y over x. We need to know what radians, what degree in radians is going to give you a tangent of -1. So let's draw, first let's draw our graph. So we are given from negative pi halves to pi halves. So here pi halves is here, negative pi halves is right over here. So we can only use quadrant 1 and 4. Let's try pi over 4. What are the coordinates of pi over 4? It's root 2, comma root 2, both positive root 2 over 2, right? So here's your x and here's your y. So tangent of that would be root 2 over 2 divided by root 2 over 2. That gives us the tangent of +1, right? But we don't want +1, we want -1. So pi 4 we can't use pi over 4. Let's try a negative pi over 4. And that has a coordinate of, since it's in the fourth quadrant, sine is negative, so it's positive root 2 over 2, comma negative root 2 over 2. So when you take the tangent of that, here's your x and here's your y, it's negative root 2 over 2 divided by root 2 over 2, and that gives you -1, right? We want -1, so our only option is negative pi 4th. So our answer is negative pi over 4. Yep. Or you could also say negative pi over 4 is the same thing as 7 pi over 4, but it's the same thing. next problem. Let's do cotangent inverse of negative root 3 over 3. So in words, what they're really asking is what degree in radians is going to give you cotangent where cotangent equals negative root 3 over 3, where alpha is in 0 to pi. So 0 to pi is the range of the cotangent inverse. They will not tell you this. You have to know this. Okay, so what is cotangent really? Cotangent is tangent is y over x, right? So cotangent is the opposite, so it's x over y. So let's draw the graph. So our boundaries is from 0 to pi, so we can only use quadrant 1 and quadrant 2. Okay, so let's try the radians of pi over 3. Pi over 3 has a coordinate of 1/2 divided by, 1/2 has a cosine of 1/2 and the sine of root 3 over 2. Here's your x, here's your y. So cotangent would be x over y, so cotangent of that would be 1/2 over root 3 over 2. The 2's cancel, so you're left with 1 over root 3, and then once you can rationalize the denominator, so you multiply top and bottom by root 3. We get root 3 over 3. Does this give us negative root 3 over 3? No, we're given positive root 3 over 3, so we can't use pi over 3. Let's try 2 pi over 3. So this is 2 pi over 3, and that has a coordinate of negative 1/2 comma root 3 over 2. And if you take the cotangent of that, it would be negative 1/2 divided by root 3 over 2. And this will give you negative root 3 over 3. So this works. So our radians should be 2 pi over 3. Okay, so that was cotangent inverse. So another one, let's do arc of cosecant of negative 2. So we can rewrite this as cosecant inverse of negative 2. So again, what is this telling you in words? So what degree in radians is going to give you cosecant equal cosecant of -2 where alpha is from -pi/2 to 0 union 0 to pi/2. So how I got this was it's basically the range of the cosecant inverse. So what is cosecant? Cosecant equals is the same thing as 1 over sine of alpha, right? So we want to get when we divide something, 1 divided by something should give us -2. That's what we want. So first let's draw the graph. So we can only go from -pi, here's -pi/2, and then here's 0, so here's +pi/2. So we can only use quadrant 1 and quadrant 4. So I will try pi/6. So this is pi/6, and pi/6 has a coordinates of √3/2, 1/2, right? What is, okay, so here's our x, and here's our y. So let's try, so the cosecant of pi/6 is, so let's try 1 over sine of pi/6. So that's like saying 1 divided by sine of pi/6 is 1/2, right? And then when you do the work, let's say we have to multiply everything by 2, so that gives us 2 over 1. It doesn't give us -2, so we can't use pi/6. Let's try -pi/6. -pi/6 has a coordinates of √3/2, comma, it's in the fourth, so sine is negative, so it's -1/2. So if you do the cosecant of that, so it's 1 over sine of -pi/6 is saying 1 divided by sine, 1 divided by -1/2, because sine of pi/6 is -1/2. Multiply everything by 2. So you're left with 2 over 1, -1, so it's -1 over 2. We get -2, right? So this -pi/6 works. So our final answer is just -pi/6. Let's do another one. Let's do tangent of arc cosine of 1/2. So first what I would do is I would do whatever it's in the print. I can actually rewrite this as tangent cosine inverse of 1/2. So what I would do is I would do whatever the parentheses, because of PEMDAS, remember PEMDAS? So cosine, let's do cosine inverse of 1/2 first. So let's do that, cosine inverse of 1/2. So we know that the cosine inverse of graph has a range of 0 to pi. So 0 to pi, so we can only use 1 and 2. So where's cosine positive 1/2? Pi over 3, right? That's 1/2, comma, root 3 over 2. So we can't use, I'm not going to use 2 pi over 3, right? Because it has a negative. This is cosine, negative cosine of negative 1/2 and comma root 3 over 2. So we don't need to use 2 pi over 3. So our only option is pi over 3. So we're not done yet. So now we gotta take the tangent over whatever that answer is, which is pi over 3, right? So we gotta take the tangent of pi over 3. So here's pi over 3. Here's your x and here's your y value. So tangent is y over x, so it's root 3 over 2 divided by 1/2. The 2's cancels, right? Crosses off. You're just left with root 3. And that's your final answer. Next problem. Let's do sine of inverse of cosine 2 pi over 3. So I'm going to do the parentheses first. So what is the cosine? What is the cosine of 2 pi over 3? If you don't know, you can always draw the graph, right? 2 pi over 3 is right here. Cosine of 2 pi over 3 is negative 1/2. Here's 2 pi over 3. So it has a coordinate of negative 1/2, comma, root 3 over 2. So the cosine of 2 pi over 3 is negative 1/2. But we're not done. You have to put that into the equation, so it's sine of inverse of negative 1/2. Okay, so now we have boundaries. The boundaries for sine inverse is, so the boundaries of sine inverse is when alpha is at negative pi half to pi halves. They won't tell you this, you have to know this. So draw the graph. So we can only use, here's pi halves, negative pi halves. We can only use quadrant 1 and 4. So what degree in radians is going to give you what degree in radians is going to give you of sine of negative 1/2? So will pi 6 work? I don't think so, because pi 6 has, it's root 3 over 2, comma, positive 1/2. So we want a negative, so pi 6 won't work. Let's try negative pi 6. that gives us coordinate of root 3 over 2, comma negative 1/2. That's our x and that's our y. So yes, it works because sine is negative 1/2. So our final answer is negative pi over 6. So first step was I did whatever's in the parentheses, so I did cosine of 2 pi over 3, which is negative 1/2, and then now you have to take the sine inverse of negative 1, sine inverse of negative 1/2, and then like the sine inverse graph, you need to know the boundaries, so alpha is at negative pi half to pi half in the sine inverse graph. Draw your graph, and then you should get always a degree in radians. So that's how I got negative pi over 6. Next problem. Let's do cotangent of negative 1 cotangent of pi over 6. So first we're going to do the parentheses. So what is we got to find out what's the cotangent of pi over 6. First of all, what is cotangent? It's the opposite of tangent, so instead of y over x, it's x over y. So pi over 6 is right here, and that has a coordinate of root 3 over 2, comma, positive 1/2. Here's your x, that's your x, and here's your y. So we got to take the cotangent of that, so it's x over y, which is root 3 over 2 divided by 1/2. The 2's cancels, so you're left with root 3. We're not done yet. We got to take the cotangent inverse of root 3. Okay, so the cotangent inverse has a boundaries of when alpha is in 0, comma pi. Yeah, so we need boundaries are very important. So 0 to pi is, we can only use quadrant 1 and quadrant 2. So what they're asking here is what degrees in radians is going to give you a cotangent of positive root 3. Let's try pi over 6. So pi over 6 has a coordinates of root 3 over 2, comma, 1/2. So here's your x and here's your y. So we want, well, this works. So cotangent is x over y, so we're going to use root 3 over 2 divided by 1 over y, which is 1/2. 2's cancels, you get root 3. So this works. We won't use 5 pi over 6 because it has we would get negative root 3 over 2, right? So oops, let me show you. So we can't use 5 pi over 6 because it has a coordinates of negative root 3 over 2, comma, 1/2. Basically, when you take the cotangent of this, you're going to get negative root 3. So we can't use that. So our only option is pi over 6. So pi over 6 is our final answer. do another one. Let's do cosine 2 sine inverse of root 2 over 2. So first of all, like the other problem we did, we got to do the parentheses first. So we got to do sine inverse of root 2 over 2. So let's find that out. Sine inverse of root 2 over 2. And we know that the inverse of sine has boundaries of negative pi halves to pi halves. So we can only use quadrant 1 and 4. So what degree in radians is going to give you sine of positive root 2 over 2? I think that is pi over 4, because it has coordinates of root 2 over 2, comma, root 2 over 2. So yeah, sine is basically the y value, so pi 4 over works. Negative pi fourth will not work, right? Because it has a sign of negative as a cosine of positive root 2 over 2, but has a sign of negative root 2 over 2. So we can't use negative pi over 4. So yeah, it's cosine of 2 times, don't forget about this 2, and we said it's pi over 4, right? Because what they're saying, sine inverse of root 2 over 2 is saying what degree in radians is going to give you sine of positive root 2 over 2, and we agree that it's the radians of pi over 4. When that simplifies into cosine of pi halves, and we know that the cosine of pi halves right here, has a coordinate of 1, 0. So the cosine of pi half is, sorry, it's not 1, 0, it's 0, 1. So here's your x and here's your y. So the cosine of that is just 0. So your final answer is just 0. Okay, next problem. We're going to do sine inverse of 2 sine of pi over 6. So, like the other problem, we must do the whatever we got to do. What is do the parentheses? So first, let's find what is the sine of pi over 6. Here's pi over 6. It has the coordinates of 6 by 4. It has the coordinates of root 3 over 2, comma, 1/2. So here's your x and here's your y. So the sine is just 1/2. But we're not done, so you got to take the sine inverse of 2, don't forget the 2, times 1/2. So that 2 cancels. So you're left with sine inverse of 1. And then the sine inverse has boundaries on, so alpha is at negative pi halves to pi halves. So it's basically quadrant 1 and 4. So sine of 1, so let's try pi half. So the coordinates of pi half is 0, comma 1, right? Yeah, so pi half works. Does negative pi half works? No, because it's 0, comma negative 1. We want a positive 1. So sine of inverse of 1 is just pi halves. That's our final answer. Okay, we'll do one last problem. Okay, so the last problem says find the inverse of f of x equals 3 sine times 2x plus 5, where alpha is in between negative pi fourth and positive pi fourth. And then we got to determine the domain of f inverse. So what I would do, I could rewrite it of the f, so we could rewrite it as y equals 3 sine 2x plus 5, right? So when you take the inverse, all you're doing is switching the y's. So we're switching the y's and x's, and then you have to solve for y. So what I'm going to do is switch the x and y's and then solve for y. So wherever there's a y, you should replace it with an x, and wherever there's an x, you should replace it with a y. So it's 3. So our new problem would be x equals sine of 2y plus 5. Now I'm going to try to solve for y. So let's get rid of this negative 5. So you're left. So you have x minus 5 equals 3 sine 2y. Let's divide everything by 3. So you're left with x minus 5 divided by 3 equals 3 cancel. So you're left with sine of 2y. Okay, I want to get rid of this sine, so I can get rid of the sines by multiplying both sides by the sine inverse, right? So you're left with sine inverse of x minus 5 over 3. This cancels, right? The sine inverse times sine cancels, and you're left with 2y. And then you divide everything by 2. And then your new equation, then if you do all the work, your new equation should equal y equals 1/2 sine inverse of x minus 5 over 3. So our inverse is basically this. So f of inverse is this whole thing, right? 1/2 sine inverse x minus 5 over 3. So they want to know, we got to determine the domain of f of inverse. So remember that if you want to take the inverse, you just switch the coordinates. So what I know is, since sine of 2x, so I'm going back to the original equation, right? Sine of 2x. The domain is between -1, and 1, right? So this is your domain of this graph, of this, of f of x equals 3 sine of 2x plus 5. Okay, so, and then the range of f, the range of f, this graph, f of x, the function, is between 2 and 8. Okay, so how I got that was, remember the amplitude is 3, right? And then we have a vertical shift of 5. So we said that the amplitude is 3, right? So and then there's a vertical shift. So our max is 3 plus 5 equals 8. And then our min is negative. It's always the opposite of 3, so it's -3 plus 5, which is 2. So that's how we got 2 and 8. That's our basically our max and minimum. That's our max and min. So the domain, the domain of f of inverse is 2, 8. Remember, inverse is when you switch the x and y. So we said that the range of f over here is 2, 8. And then so if we switch it, the domain, if we switch the x and y's, we still get 2, 8. So this is our final answer. So that's your final answer, and that's pretty much it for today. So I'll just review. So basically, I just switch the x and y's, and then solve for y, and then that's how I got f of inverse. And then you just switch the x and y values, because we said that the range is 2 to 8 of this function, and so the domain, the range of f is 2 to 8, so the domain of f of inverse is 2, 8.